Hi everyone, I'm going to go ahead and record the answers rather than do a live lecture. I think this works just as well, and I will go ahead and post it for you. There were a couple of good questions, so I wanted to make sure everyone was clear, and I'm hoping that this will help clarify some of the things that people were struggling with. So I got a couple of questions about measures of central tendency. And in particular, a couple of questions about the median. Remember that there are three measures of central tendency: the mean, which is adding all the scores together and divide by how many scores there are; the median, which is the middle point of the distribution; and the mode, which is the most frequent score. So one of the questions was about how you calculate the median. So if, for example, you're given a set of numbers that are out of order, the very first thing you need to do is arrange them from lowest to highest. Okay, so I've reorganized these numbers. They're exact same numbers, just in different order. So that's the very first thing you do. This would be easier with a stylus or something, but basically what you're going to do is cross off each end. So cross off the first two and the last 7, then I'm going to cross off the next 2 and the next 7, then I'm going to cross off the 4 and the 6, the second 4 and the 5, and so the goal is to try to find those numbers that are exactly in the middle. If you have an odd number of numbers, then you're down to one number, which is great. If you have an even number of numbers, then you end up with 2. And so what you do is, if you have 2 numbers after getting those numbers that are the midpoint, then you take out the mean. You take the mean of the 2. So in this case, the median is between 4 and 5. We add those together, divide by 2. We get a median of 4.5 for this set of numbers. Okay, somebody also asked about kind of manipulating some of these scores and how researchers might manipulate them. There's certainly these rules about how you calculate them, but sometimes they can be manipulated in terms of how they're reported and how you deal with outliers. So this is a nice example. So this is something that, like, you might see in the news media. It's a distribution of family incomes, and so each little green man represents a family. And so if you take the mean of all these families, you would say the mean family income of these participants is $70,000. If you look at this, it does not actually look like that's an accurate depiction of how much the average person is making. There are many more people on the low end and very few people on the high end. The reason for that is particularly the mean can be skewed by very high values. So those families that are making $475,000 or $710,000 a year are really heavily skewing the mean, so it looks much bigger than it actually is. These are called outliers. And so if you wanted your sample to look like it had a higher average income, you might use the mean. However, if you wanted to maybe more accurately depict what most participants in this study look like, you could use the mode, or the most frequent response. In this case, that's 20, or the median, the middle response, which in this case is 30. And so the $20,000 or $30,000 seems to be really more representative of what the typical participant selects or makes in a year, or the typical family. But depending on the purpose of reporting on this information, you might intentionally select the mean, which is higher, or avoid the mean to get your point up across. So these are the kinds of things that sometimes can be done to kind of manipulate these averages and to be on the lookout for. Okay, I also got a lot of questions about the confidence intervals, and so I wanted to kind of go over, and I've got an example for you. But remember that we talked about 2 different kinds of confidence intervals. So the very first thing, if you have a confidence interval problem that you need to solve, is asking, what kind of confidence interval is it? If it's a confidence interval around an estimate of one mean, you're talking about just one number and you're getting the confidence interval around that mean. So we've got the formula here to get the upper limit. It's the mean plus the t-value times the standard error of the mean. If it's the lower limit, it's the mean minus the t-value times the standard error of the mean. But we also might get the confidence interval for the difference between the two means. So any problem that you have that's talking about two different groups, if it's asking you about confidence interval, it's probably asking you about the confidence interval for the difference between those two means. And really what this is asking is, are we sure that the population means would be different if we found a difference in the sample means? So that if the confidence interval includes 0, there will be no real difference between those means. So if you're looking at a difference between two means, you're going to use the same general formula, but it's going to look slightly different. The confidence interval between two means is the difference between the means. So M1 and M2 are for mean 1 and mean 2. Okay, so you can really, as long as you use them consistently, the actual order doesn't matter. It'll just flip whether it's negative or positive. Your conclusions will still be the same. So you look at the difference between the means for the two groups, plus or minus the t-value times the standard error of the difference between the two means, which I will always give you. Okay, so let me give you an example and kind of walk you through how you might solve this. So in this example, a developmental psychologist investigates the effects of mothers' carrying behavior on infant sleep patterns. The psychologist trains 20 mothers in carrying methods that press the newborn's head against the mother's breast. The other 20 mothers are not instructed in carrying method at all. All mothers record the number of hours their newborns sleep in a 24-hour period, and we've got the mean sleep period for infants in the instructed group and the uninstructed group mean, and then the standard error of the difference between the two means. Okay, so we've got these two different groups, one of which got the intervention and one didn't, which is going to give you a hint. And the two questions are, can you calculate the 95% confidence interval for the difference between the two means? And then what can we say about whether that training or intervention was effective? Okay, so the first question is this a confidence interval around one mean, or is it about the difference between two means? We're comparing two groups, the group that got an intervention and the group that didn't, which gives us the hint. The question also tells us that we're looking at the difference between the two means. So this is the formula that we're going to use. We're comparing the difference between mean 1 and mean 2, plus or minus t times the standard error of the mean. Now, the problem has given us all of the information that we need. So mean 1 is 12.6. That's the intervention group, I believe. Mean 2 is 10.1. I looked up the t-value, so that's 2.04. And then the standard error of the difference between the two means is 1.77. So we can go ahead and plug these numbers in to our formula. And so we get the upper limit. The difference between our two means is 2.5. We put everything else in, and we get an upper limit of 6.11 and a lower limit of minus 1.11. Okay, so if you think back to, didn't hide that last point, but if you think back to the first thing we said about these confidence intervals, difference between the two means, the big thing we're asking is, does the confidence interval include 0? Our final confidence interval was minus 1.11 to 6.11. Yes, it includes 0, which tells us, right, from -1 to +6, 0 is in that window. So there is no true difference between the means. If, for example, our confidence interval had been +1 to +6, that would not include 0, which tells us that there is in fact a difference between the two means. It tells us that mean 1 is always consistently bigger than mean 2, so we can be confident that there is a difference between these groups. But if the confidence interval includes 0, it tells us that it's possible the order is flipped. So mean 1 could be bigger, is bigger most of the time, but in some estimates, mean 1 is actually smaller, which makes us uncertain. So the second part of the question and kind of the verbal part of interpreting confidence intervals is what may be said about the effect of training based on an examination of the confidence interval for this experiment. What can we conclude about the training or about the intervention? Because the confidence interval includes 0, we cannot conclude that there is a true effect of training. We cannot be certain that the trained group will always do better than the untrained group. Okay. So hopefully that helps with confidence intervals. The final question, which I did post on the discussion forum too, because this one is pretty straightforward. Someone asked about the tables and figures that you need to include. You do need to include them because we're all looking at the same outcome. I went ahead and made the tables and figures for you, and all you need to do is copy and paste them into your paper. They are in the results and discussion PowerPoint, but I've also discussed them in the results and discussion lecture. So I'm hoping that this helps clarify things. Okay.